All right. Hello, can you hear me? No? Okay. Good evening, everyone. How is everybody? Okay. First, some reminders about important dates. The first one coming up, written assignment 2, February 16 at 4:30. Please complete the assignment well before the due date, as last-minute unforeseen events may occur, technological glitch, personal situations. Okay. There will be no extension for written assignment 2. And next week is the reading week, no class. Next week is not reading week. Yeah, it is reading week. It is also a family day on next Monday. Okay, happy family day. Hope you all spend time with your families and loved ones on next Monday. So where we are in the course syllabus. Today is week 6. We are in week 6. We are going to complete chapter 4, session 4, and session 5. After reading week, we'll start chapter 5. Okay. So that is a brief reminder about the upcoming dues. Any questions? Yes.
Just in regard to the first written assignment, do we have an idea of what we might see our feedback from those assignments?
Written assignment 1, the TA just marked your assignment. Please stay tuned for the feedback for your written assignment 1, as well as the test 1 result. Okay, please be patient. We have a course coordinator, Professor Mark Willoughby. He is responsible for all the 3 different sections, the mark distribution, the result distribution. Okay. Any other questions? Yes?
I'm sorry, I can barely hear you right now. I can barely hear you right now, I'm sorry.
I'm sorry?
I can barely hear you.
Sorry, is that okay?
Yes, thank you, sorry about that.
Okay. Other questions? Okay, so week 6. Session 4 of chapter 4. Absolute extreme. Remember last class, we discussed the relative extreme, relative minimum, relative maximum. And here we are going to introduce absolute extreme. This graph is shows the average age of cars in use in the United States beginning 1946, that is time 0, until 2009. As you can see, for the first 12 years, the average age of the class declined, and then increased a little bit, decline again. So the overall trend in the last 40 or 30, 40 years are increasing. And in this graph, we have absolute minimum. So there are 2 points. Absolute minimum means those 2 points are smaller than any other points in this graph. We also have a maximum. And this point is greater than any other points in this graph. So the definition of absolute extreme, if fx smaller or equal to fc, for all x in the domain of f, then fc is absolute maximum. If you look this inequality from right to left, you see fc greater or equal to fx at all points. fc greater or equal to fx. So fc is an absolute maximum. On the other hand, if you have fc smaller or equal to fx, fc is absolute minimum. So this is the definition. Theorem 3, if function f is continuous on a closed interval AB, then f has both an absolute maximum value and a absolute minimum value. And where the maximum and the minimum happen, it could happen anywhere within AB, or it could happen at A, it could happen at B. Okay, 3 possibilities: open interval AB, at point A, or at point B. This is another example of absolute maximum, absolute minimum, relative maximum, relative minimum. So this point is absolute maximum because this point is greater than all the points in this graph. And this maximum happened at point B. Maximum happened at point B. And we also have this point is absolute minimum. This absolute minimum happened at point x3, and x3 is in the open interval A and B. And we can also find the relative maximum here. Relative maximum means this point is greater than the point nearby. So this point greater than here, but this point is smaller than this absolute maximum. That's why it is relative maximum. Similarly, this is relative minimum. Questions? So now, how do we find absolute maximum? How do we find absolute minimum? 3 steps. Step 1, find the critical value. Step 2, compute the value of f at each critical point, and then compute fa, fb. Step 3, find the maximum and the minimum value from step 2. Okay. So this is the procedure from maximum, minimum. Let's take a look at example. Find the absolute extreme of the function f(x) equal to x squared, defined on the interval -1 to 2. So first of all, we examine f is a continuous function. And then we found the derivative of f(x). When you let derivative equal to 0, you can find the critical point. Okay, so critical point is x equal to 0. So we completed step 1 and step 2 here. So step 1, found the critical, just completed step 1, found the critical numbers. The critical number is x equal to 0. And after that, we do step 2. We compute the value at the critical number and we compute FA, FB. So this is the critical value, x equal to 0. So I need to calculate what is f0. So original function fx is x squared. So f0 equal to 0. And then this is my a equal to -1, b is 2. I also need to compute f -1. Okay, so it is -1 squared. And I need to compute f2 because 2 is b. Now I completed step 2. Compute f value at a critical point and compute FA, FB. Step 3, during step 2, found the maximum value. In step 2, I got 0, I got 1, I got 4. Which one is the maximum? 4. So then I conclude when x equal to 2, you have maximum. Okay. And which one is the minimum? 0. So the maximum is 4, minimum is 0. That is step 3. So step 1, found the critical value. Step 2, compute the critical value and compute the endpoints. Step 3, make comparison. Any questions on how to find absolute value? The graph of this one, we all know y equal to x squared is parabola, but it has the interval from -1 to 2. Okay, so the graph is start here, end here. So this graph, which one is maximum? This point is maximum. Okay. And this point is minimum. So absolute maximum, absolute minimum. And this point here, I can say it is relative maximum because if you consider just this part, this point is the maximum of this part. Okay, so this point can be considered relative maximum. Any questions? So that is session 4, okay, maximum. Session 5 is optimization. It has a wider application in economics and business. Okay. So there are some guidelines for solving optimization problem. I will use the example to illustrate this procedure. So, fencing a garden. A man wishes to have a rectangular shape in his backyard. He has 50 feet of fencing with which to enclose his garden. Find the dimension for the largest garden he can get if he uses all of the fencing. So this is a typical example, maximum the area. Okay. And this question has the constraints. This person only has 50 feet. Okay, and you want to create a rectangle so that the area of this rectangle is maximum. So if you add all these three sides together, so if you have A, B, C, D, because this is rectangle, A equal to C, B equal to D, okay? So let's just assume this one. So if you add all the sides together, it is 50. The area of this rectangle equal to base times height. What you want to maximum this area given all the sides are together is 50. This is the question. So, and how do we solve this question? We set this rectangular, okay? Height is X, okay, width is Y. What we want to calculate the area of this rectangle. Okay. So we use letter A represent the area. Area is X times Y. So remember this is X, this is Y. Okay. And then we have constraints. Because this is X, this is also X, and this is also Y. So 2X plus 2Y equal to 50. Questions so far? Yes.
Why is it 2x plus 2y and not 2x times 2y?
Thank you. The question is, this person has 50 feet of fencing. Okay, if you imagine you have 50, you want to make this 50 into a rectangle. Okay, so all the sides, if you add together, it is 50. Okay, because it is rectangle, so we tend to use, so this height, this one is X, this part is Y. Okay, so X plus Y, actually it is just 25. Because the whole add together should be 20. If you add, this is also X, this is also Y. Should be 50. Add 4 sides should be 50. Why not 10? Because this is the length of the fence. Okay. Thank you for asking, and this I should use X times Y. X times Y, this time you need to multiplication. We want to find the area, you need multiplication. Okay, so we did this one. So now the problem becomes, how do we make A equal to XY maximum? Under, okay, maybe I'll rewrite it. So what we are going to do, we want to maximum A equal to XY such that, means under condition, such that 2X plus 2Y equal to 50. So this is our mathematics model based on the description. we want to maximum x times y subject to 2x plus 2y equal to 50. Okay. How do we solve this solution? Because 2x plus 2y equal to 50, I can solve for x. 2x equal to 50 minus 2y. Or you can solve for y, doesn't matter. And then x equal to, both sides you divide it by 2. You go to 25 minus y. And plug this x into the area. So a equal to x times y. X equal to 25 minus y times y. Okay, expand this expression, you go to 25y minus y squared. And what is this 25y minus y squared? Quadratic function. Quadratic function. And this quadratic function has the maximum. How do I know? Because the coefficient of the second degree is negative. This parabola quadratic equation, this is down. Okay, that's why we have maximum point at here, because this is a negative. Okay. So the problem becomes, how do we find the maximum? 3 steps here. Remember we did found the maximum here. This example, how do you find maximum for this one? And here, similar, we just use different letter. Find the maximum for this function, 25y minus y squared. Find the maximum for this function. Is that clear? Find the maximum for 25y minus y squared. And basically, you repeat yourself for this example. In this example, how do you find the maximum? You go 3 steps. Similarly, how do you find the maximum for this one? You go 3 steps. Okay. So step 1, find the critical value. So take derivative of 25y minus y5. Take derivative. So the derivative is 25 minus 2y. Let derivative equal to 0, you found the critical value. Y equal to 25 over 2. Equal to 12.5. Step 1, found the critical value. Okay. And then step 2, calculate the value at critical value as well as the interval. The interval is because this problem, the interval we are constricted to the closed interval is 0 to 25. Why? You have a 50, the length of the function is 50. Okay? So if you want to make rectangle, the minimum is 0, the maximum is 25 for the x or for the y. Okay. You cannot make it, for example, 26, for example. Can x or y be 26? No. If it is 26, the whole length would become 54, right? But our given condition, it is just 50. Okay, so the maximum value of x or y could be 25, the minimum is 0. Okay, So now, once we identified the interval, we then, so we did step 1, calculate critical value. Step 2, found the F value at this point, at the critical value. So plug in 12.5 into this function, into 25 times 12.5 minus 12.5 squared. So what is that number? I will try to open a new worksheet. So what I try to do, I try to calculate what is 25 times 12.5 minus 12.5 squared. The result is 156.25. So this is the F value at point 12.5. And then you have to calculate what is the value at 0. When y equal to 0, it is 0. So 25 times 0 minus 0 squared, it is 0. And then you have to calculate the value at 25. So it is 25 times 25 minus 25 squared, it is 0. This is step 2. Calculate the function value at the critical point and at the end point A and B. A is 0, B is 25. Step 3, found the maximum value in step 2. So we got this 156.25 is the maximum value. So we found our solution. So this person, if you have 50 feet of fencing, you should let x equal to 12.5, y equal to 12.5, so that the area is maximum. Yes?
Won't this make a square then x equals to 12.5?
Thank you. Thank you for your observation. The question is, when x equal to y, it is actually square. You are right. When you make it a square, the area is maximum. Any other solutions, the area you get is smaller than the square. Now, can somebody give us example? Make 50, use 50 to make rectangle. So what could be x, y value? Can somebody give us other values rather than 12.5? Can you create other numbers? You just need to find two numbers such that x plus y plus x plus y equal to 50. What could be x? What could be y? That is the question. Yes. X could be 10, y could be 15, perfect. If you plug in x is 10, y 15, you got equal to 50. So if you do this, your graph will be looks like this, maybe. This is 10, this is 15, but the area of this one, it is just the area 10 times 15, 150. What we get, the area we get is 156. Your area is smaller than my area. And my area is the maximum area. You could find another value. Can somebody give us other examples? What could, yes?
Could you do 24 and 1?
Thank you so much. X is 24, Y is 1. Perfect. Thank you. So when X is 24, Y is Y. So this is X, 24, Y is 1. Fantastic. And the area is just 24 times 1. The area is 24, much less the area. I got area 156 using maximum. Try 12. Thank you so much. 12 and 13 is very close to my maximum value. Thank you. If you try, one is 12, the other is 13, fantastic. So 12, 13, the area you get is 12 times 13. Okay, so what is 12 times 13? $156. You got 156, but I got 156.25. This is the maximum area. You cannot find any other number bigger than my area here, 156.25. Yes. Yeah, that is the maximum. That is our objective. We want to find, use limited material. This is the limited material. How can I make an area that is maximum? We have several solutions. It could be X equal to 10, Y equal to 15, fine. But the area is smaller than the maximum area. And your number is excellent. It's very close to the maximum. Any questions? From this example, you can see the value of mathematics model. If you just use the guess, you see we guess many numbers, okay? We guess many numbers, but we have scientific way, step by step, to find the maximum without guessing. Questions?
So if there are questions like this in the future, does it matter if it's a rectangle?
The similar question in the future, the answer is yes. If you're given a string, you want to make it an area, the answer is a square. We will make the biggest area. Yes?
I think the answer should be 12 and 15 because it wishes to have a rectangle.
Say that again.
I guess the answer should be 12 and 15 because he wishes to have a rectangular garden instead of a square.
I'm sorry, I didn't get your question. Can you rephrase your question?
Like it's written in the question that the man wishes to have a rectangle shaped garden and if we put x equals to 12 and then it would be a square instead of a rectangle.
Okay, this comes up. Now I understand your question. The question said this man wants a rectangular. In geometry, some people believe this square is a kind of rectangular. Okay, so square is a special situation of rectangular. Thank you. Okay, so any other questions? If the question is circular, okay, you are thinking that's great. If we want to use this 50, create a circle instead of rectangular, it is a fixed area. It is just this size. You cannot change the size. You can imagine giving you a string, you make it a circle. The size is just one size. You cannot change the size area. Okay, so we solve this mathematically using the derivative, found the maximum. How do we use technology to find the maximum? Okay, how do we use technology to find the maximum? Now I'm going to go to Excel to demonstrate this procedure. Okay, use Excel. To use Excel, I will open an Excel. I'll try to make so now in Excel we are going to use the solver, S-O-L-V-E-R solver. Okay, how do you find the solver? You go to, I already installed solver. So if I go to data, I have solver. It is the same procedure. How do you get data analysis? Okay, if you're using Windows, you go File, Options, okay, and you have add-ins. And then you click Solver, Add-in, and click Go button, and then click OK button. That's it. How do you install Solver on your Excel? Solver Add-in. Okay, I already did this. So I have this solver. So now you type in X and Y. We all know what is X represent, Y represent, length and height. Okay. So your objective is to create an area so that the area is maximum. Okay. If we just want to, so we don't know X is what, Y is, so we don't know those two values. We don't know, okay? But we can do the area. So this number in cell A2, we don't know. We want computer give us number. What is X, what is Y? So A2 times B2, that is my area. Height times width is the area. Okay. Oops. So this is my objective. No. On another hand, I know 2x plus 2y equal to 50. So that is my constraints, okay? Condition, okay? So I know this is unknown, okay? But I know if I use 2 times x, I don't know what this number is. It is empty now, this number, okay? Plus 2 times y, okay? And this number should be equal to 50. But right now it is 0 because I do not have number here. My objective is to find these two numbers. Is that clear? I want to find these two numbers with the yellow background. Okay. So now you set up your objective function and your constraints. By the way, if you are business students, you studied ITIS 1P97, you should know this, okay? So after that, I go to data, solver. So set objective. Where is my objective? This cell, this area is my objective. I want to maximum the area. But sometimes we want to minimum. For example, if it is economics, business situation, you want to minimum the cost. Okay. So we want to maximum our area by changing cells. This time we select A2, B2. We want to find out what is A2, what is B2. Okay. Subject to condition. So I will add a condition. The condition is 2x plus 2y equal to 50. This is the condition. 2x plus 2y equal to 50. Where is my 2x plus 2y? In cell C3, I created formula 2x plus 2y. Okay. I click OK button, and then make sure the method you select GRG nonlinear. Then you click Solve button. Just click OK button. See, you got those two numbers. X 12.5, Y 12.5. And your area is 156.25. So this is the Excel solver to solve the maximum problem. Any questions? All right. So I demonstrated this slide. Okay. All right. So another example, packaging. BT Malt Company requires its corned beef hash containers have a capacity of 54 cubic inches, have the shape of right circular cylinder, and made of aluminum. Determine the radius and height of the container that requires the least material. Okay. So this is the question. Looks like this question we just have one number, 54. That is the capacity of cubic. So the best way we draw a diagram. Okay, this is the container. Okay, and this is we use R represent the radius from here to here. This is the R. H represent the height. And we want to minimum the amount of material used to construct the container. So step one, we just use letters to represent some measurements. And then step two, we found the area. If you want to construct this shape, the area has three parts. One is on the top. This is the area. You need material to cover it. The other is on the bottom. Both the top and the bottom are circle, is a circle. Okay. And then you need the area on the side. This is the area on the side. Okay. If you have the area on the side, if you take it out, it is actually a rectangle. Okay. If you take this out, it is rectangle. That's why the rectangle, this is the rectangle. And this is the two, this is on the top, the other is on the bottom. You have two. One is on the top, the other is on the bottom. Each is a square, each is a circle. The area of the circle pi r squared. The area of the circle is pi r squared. Okay, and this, if you take this out, you need to find the circumference of this circle. What is the circumference of this circle? The circumference becomes the width of the rectangle. Did you see that? If you take this out, it is rectangle. The height of the rectangle is h. What is the width? The width is this one here, the length of this one. And what is the circumference of a circle? It is 2 pi r. 2 pi r is this one here, 2 pi r. Okay? And then times h, you get the area of this part. What is the area of this part? 2 pi h, 2 pi r, then times h. Okay. So this is this part. So any questions? What we want to minimum this expression. Minimum this expression. How do we minimum? This is our objective. And we also have constraints. We also have condition. This is the volume of this container. The volume is 54. Okay, the volume is 54. This is our condition, constraints. Okay, so how do you calculate the volume of this shape? The volume equal to pi r squared times h, that is the volume. Volume equal to 54. Any questions so far? So now our question becomes what we want. We want to minimum this one such that pi r squared h equal to 54. And this becomes our mathematics model. Maximum 2 pi r squared plus 2 pi r h such that pi r squared h equal to 54. And we are using two methods. One, strictly mathematics derivative. Two, use Excel. Two different methods will give you the same answer. Okay. I will demonstrate Excel first because Excel is very fast. Okay, when we do the derivative, we have to do a longer process, go through a longer process. Okay, so we have two variables here. One is R, the other is H. So now I'll go to Excel. Okay. I will delete everything, maybe use another worksheet. So we have two variables here. One is increase the font size so that you can see clearly. We have R, we have H. I want to find what is the value for R, what is the value for H in these two cells. I don't know. I want to find those two values so that, and I have my objective. My objective function is to minimum the material, the area. Okay, so I know the area equal to 2 times remember mathematics pi, okay, this number, and times This number is R. I don't know, but I will find out. This number is R. So 2 pi R squared. Remember, this represents the area on the top, the circle, and the area on the bottom. And then plus the area, the rectangular area. 2 pi then times R times H. So this one is the equivalent of this part here, 2 pi R squared plus 2 pi RH. That is my objective function. My objective function, 2 pi R squared plus 2 pi RH. Okay. And now I need to enter this one. Pi R squared H equal to 54. Okay. So this is my constraint. Pi R squared. Pi R, this is R squared. This is my pi R squared. Okay. And this one, hello, no talking, please. Thank you. So I want to minimum C2 such that C3 under condition C3 equal to 54. Did you see it? Okay, now I want Excel, let's do it. So go to solver. I will reset all. So set objective. C2 is my objective. This time, I need to select minimum. I want to use the minimum material. Set C2 to minimum by changing the cells RH. I don't know R, I don't know H. I let computer solve it. Subject to constraints, click Add button. So the volume in C3, it is volume. Volume equal to 54. Equal to 54. Volume equal to 54. Click OK button and make sure GRG non-linear is selected. Then click Solve. Click OK. I got this result. It now looks like not expected because I got H0. Let me see. Because if you use the calc, we shouldn't get that. Let me see. 54. This is my Excel. This is answer I get. R equal to 1, H equal to 2. Maybe I need to double check the formula for objective function here. See, okay. I'm not this one. Maybe shall we take a break? During the break, I will try to figure out what's going on. Please come back at 7:05 break time, guys. I try to figure out what's wrong with my Excel here.
for the statistics meeting. I'm having a statistics meeting on Zoom, and it's clashing with the dates I'm having my fundamental consensus meeting.
Statistic?
Yes.
What is your question?
I said that the date for the meeting is clashing with the date I'm having my geosciences meeting.
Can you email me? Or later, because I'm troubleshooting a problem, okay? Yeah. Can you wait for the next break? Okay, questions? Yeah.
There's a program. Active program. So that 15 years is now. I always want to use to go into the university program and I wasn't. So I was complacent what I was doing as a college, so I don't know what. I got requisites to put up 2 years. Now I'm empty yoke, empty on the so she gets a good passion about. Yeah. So it's older? Yeah, she's maybe 4 years of the dragon. Typically 5, 7 years. I can have 4 courses. So we only have 5 years. Yeah, and then 2 more than I graduated. It could, but I want to believe it in the matches because I want to get some experience using the working on vertical process. We have the vertical process, but I'm going to focus more on data programs. Yeah. It's 7. I didn't want to make it obvious, so I didn't want to go.
I'm saying there is one. I can do the whole thing.
Yeah, I actually wanted to do it for 4 years, but I'm also learning at the same time. So I'd rather do those courses at 100%. So I just thought, okay, keep going before you get so. Yeah. Yeah. Yeah, it's kind of a little bummer that too, but something that it kind of gets aside. Yeah. Oh man, I missed it so long. I can give it to
All right. Hope you have had a nice break. Any questions before we continue? Okay, now I will redo the Excel demonstration. So this objective function, it is actually two pi r squared plus 2 pi rh. This formula is in cell C2. And then in cell C3, it is our constraints. Okay. So this is the formula in cell C3. It is pi r from h. Actually, there is not equal to 54. It's just pi r from pi r squared times h. Okay, now we go data and then go solve. Set objective function C2 to minimum by changing cell A2, B2 subject to the constraints C3 equal to 54. The mistake I took before the break, I missed this h. I just typed in pi r squared. You have to times h. That is the mistake I got. And then you click the solve and click OK button. No result. Double check my pi r squared. And this one, 2 pi r squared plus 2 pi times r times h. Maybe I need to reset all. And then set objective function C2 to minimum by changing cell A2, B2 subject to C3 equal to 54. Click OK button and click solve. What happened? Couldn't solve. Quickly retyping. We need to find R and H. So those two values we need to find out. And we know our objective function is equal to 2 times 2 pi r squared, 2 pi. This is r squared plus 2 pi r h. Okay. Double check my formula. This is the objective function. So 2 pi r squared plus 2 pi r h. Okay. And then the constraint is pi r squared pi r squared times h. So this is the constraint, pi r squared times h. Now I go to data solver. Set objective function C1, not C1, C2. C2 to minimum by changing the cell A2, B2, subject to constraints C3 equal to 54. And I quick solve. I just did it. I got the number R and H and pi r squared equal to H. And this one, 2 pi r squared plus 2 pi r H. So maybe I will leave this later. Don't know why. I just did it. I can solve it, but now I cannot solve it. Sorry for that. Let's move on to algebraic solution. Okay, then we can come back to the Excel. Okay, let's restate the problem. We want to minimum this function subject to pi r squared times h equal to 54. Okay, so this is our objective. And how do we do that? First of all, use pi r squared times h equal to 54. We solve for h. Our objective is to eliminate one variable. Right now we have two variables, r and h. We want to eliminate one variable. So we get h expression and plug in this h into the area. So this is so that we only have one variable r. And once we get here, we take the derivative of this s. But first of all, we need to identify the interval. Okay, so r is greater than 0. And this is the graph, how that function looks like. Which function? This 2 pi r squared plus 108 over r. So this is how this graph looks like. And then we take the derivative. Take derivative, this is my s. Find the derivative of this s relative to r. So we get 2 pi times 2r. We are taking derivative. Okay. And then taking the derivative of r, it is negative r. Okay. So this is we found the derivative. After you found this derivative, set the derivative equal to 0 and solve for this r. And we get r roughly equal to 2. And so this is R. Next, we'll show that this value R give absolute minimum. To show this, we'll compute the second derivative of S. Second derivative. And we solved for R. Second derivative equal to the purpose of the second derivative is to show it has the relative minimum. And then we are going to show this relative minimum also is the absolute minimum. And then we solve for the H. Once we get R, we solve for the H. So H equal to 2 times R. So H is 2 times R. So this is, I got Excel set up here, but I could, let me see here. I got one is R equal to 2, H equal to 4. That is the correct answer. Let me see, do I have a note here? So any questions for this one? It is a little bit complicated using the algebra. I'll try one more time for the Excel. Wondering why. I troubleshooting the problem before I took the break. I got R equal to 2, H equal to 4. But when I come back from the break, it gave me trouble again. Let me see. R and H. I'll make sure my cell function, the format cells, the number is general. Shouldn't be general, should be the number. Should be the number. And then these two also should be the number, not general. Number. Okay. And I'll double check the formula. This is a 2 pi r squared. This one is 2 pi r squared plus 2 pi r h. Pi r h. And this one pi r squared times h equal to 50. Try one more time, reset. So set objective function C2 is my objective function to minimum by changing the cell subject to C3 equal to 54. So C2 minimum, A2, B2, subject to C3 nonlinear solve didn't work. I will find later, okay? Sorry for the problem. I think we may move on. Oops. To another problem, inventory problem. Let's take a look at the specific example here. This company is the sole agent of Excalibur motorcycle. Management estimate that the demand for this motorcycle is 10,000 per year. Demand that will sell at a uniform rate throughout the year. The cost occurring in ordering each shipment of motorcycle is 10,000, and the cost per year for storing each motorcycle is 200. So that is the context. So I pause for a moment to let you digest what are those numbers, the meaning of each number. So this 10,000 is the demand for motorcycle. And then the cost in ordering each shipment is 10,000. The cost for each shipment. And $200 is the cost per year for each motorcycle. So what is the question here? The question is, how large should each order be? And how often should the order be placed? That is the question. That is the question. So to solve this question, I'll go back to the original given question. And I will use X represent the number of motorcycles per order. So this is per order. Each order I have X motorcycles. And Y, that's Y represent orders per year. How many orders? 2 orders, 3 orders, or 5 orders? This is Y. Orders per year. And also we assume when a shipment arrives, the previous shipment just sold out. That is assumption we made here. So we assume each shipment arrives just as the previous shipment has been sold. Because of this reason, the average number of motorcycles is X over 2. The average of motorcycles in storage is X over 2 because we have this assumption. Okay. And once we understand we have this assumption, we can set the mathematical model. Okay. And we can use letter C represent the cost. Okay. And the cost, remember Y represent orders per year, 2 orders, 3 orders, 5 orders, 10 orders. That is Y. Okay. And we have each order, see, each order. Order is the shipment, the same thing. Each shipment is the same as each order. Okay. Each order will cost 10,000. And now I have Y orders. So you tell me what is the cost for ordering. Each order costs 10,000. Now I have Y order. So times Y. If I have 2 orders, times 2. I have 5 orders, times 5. Now I have Y orders. So that is the ordering cost. And we also have the storing cost. Okay. Each motorcycle costs 200. And how many motorcycles I have in storage? X over 2, Y over 2, because we assume when a shipment arrives, the previous shipment just sold out. So this is our objective, OBJ, our objective. And the constraint, subject to constraint, look at this one here. The demand is 10,000 per year. The demand is 10,000 per year. Okay. So that's what is the demand. We have each order, I have X motorcycle. How many order I make? Each order has X motorcycle. How many order? Y order. So total, this is the demand, 10,000. And now we have this model, we just solved it. This is important here. So we have objective function, we have constraint. Any questions on set up the models? Yes.
Just double check the objective. Is it 200 times X over 2?
Yes,
Okay.
200 times X over 2. And now let's solve this. From this equation, X times Y equal to 10,000. We get Y equal to 10,000 over X. Is that right? And now plug in this Y into the cost function. We have a C. C equal to 10,000 times Y y is 10,000 over x plus copy down 200 times x over 2. We got C. Any questions? Yes.
So is this something you would put after you have created the objective and then the subject? So that you put that 10,000 times 10,000 over x plus 200 times x over 2 under the subject as a step-by-step process?
Okay, step 1, I solve for y. What is y? From this equation, x times y. Step 2, I plug in this y into cost function c. I just did 2 steps so far. Step 1, y equal to 10,000 over x. Step 2, plug in this y into c function here. This is step 2. Okay. And now I simplify my step 2. Okay. Simplify my step 2. So this is 10,000 times 10,000. 10 raised to power, I have 80 over x plus 200 over 2, it is 100x. That is my C. Any questions? Once I get C, I take the derivative of C. Take derivative with respect to x. Take derivative. 100x take derivative, it just becomes 100. And this is 1 over x. 1 over x derivative is negative x squared. 1 over negative x squared. And there is a coefficient. The coefficient is 1 followed by 8 zeros. This is times. So I take the derivative of C. Take derivative of C. And then let derivative equal to 0. Solve for x. And to solve for x, I get the result. Solve for x, derivative equal to 0. And then 100 equal to 1 followed by 8 0 times 1 over x squared. And both sides divided by 100, I got 1 followed by 6 0, 1 over x squared. And then x squared equal to 1 followed by 6 0. And then x equal to positive negative 1 followed by 3 0. But x represents number of motorcycles. So x could not be negative. So I I discard the negative value. So X is just positive 1,000. Okay, so I got the X value. Next, we found the second derivative. The purpose of the second derivative is to see if we have maximum or minimum. So this is our C prime first derivative. And then take second derivative of C. Second derivative of C. And you will get 2 followed by 80 over x raised to power cube. The second derivative. And this second derivative is greater than 0. That's why we say we have a minimum value. If second derivative greater than 0, we have minimum value. We have minimum value at x equal to 1,000. And when we solve for x equal to 1,000, we can plug in back to here to get y value. If x equal to 1,000, y equal to how much? 10. When x equal to 1,000, y equal to 10, based on this relationship here. So our final answer, we should order 1,000 motorcycle per order. How many order we should order? 10 order. So the answer is X. Final answer, X is 1,000, Y is 10, is my final answer. Any questions? Now I try to use Excel. Hope this is not to solve this question. Okay, I will rewrite this objective function to 200 over 2. It is just 100 here. I will just write down 100 times x. 100 times x. So this is my objective. And this is my constraint. Okay. Where's my Excel? This one here. Result for here. Maybe I'll use this area here. Okay, so as usual, I need a XY. I need XY. I also need to reference the. So I need this formula here. Okay, need this formula. So I don't know x, I don't know y, but I know objective function equal to $10,000 times y, B2 is my y, 10,000 y plus 100 x, x is A2. 10,000 y times 100x, that is my objective function. And then, oops, good. Retyping the formula. 10,000 times y plus 100 times x. So this is my objective function. Then the constraint is x times y equal to 10,000. X times y, that is my constraint, equal to 10,000. Okay, now I go to solver. I reset all. So set objective C2 to minimum by changing the cell A2, B2. Subject to constraint, quick add, C3 equal to 10,000. Click OK button. Double check everything. C2 minimum, A2, B2, C3 equal to 10,000. I click solve. I still don't get the answer. Not sure why. Maybe I need to open a new Excel. But so anyway, this is the procedure. I did the first demonstration successfully. The later examples using Excel, I got some problem. I will find out later. Okay, I will update on you about that. Okay, so that actually concludes our chapter 4. Two sections. This is 7 years. So we did chapter 4, session 4 and session 5. Okay. And we solve for the extreme maximum, extreme minimum, and solve for optimal solutions. The lecture ends. Since we do have some time, it is just individual question period. If you do not have questions, feel free to go. If you have questions, any questions, stay here. I'm happy to answer your question. Thank you for your participation. Happy Family Day and happy reading week. I'll see you in 2 weeks. Okay, thank you.
I have a question about the contest.
Oh, sure.
Like there was a question in which we have to simplify the expression.
Uh-huh.
In which we do not have to simplify the expression. So like if I had simplified it, so like the marks get deducted or not?
It is computer test. I'm not so sure because I haven't got the result from our course coordinator yet. Give me 1 second. I need to do something for. Wait until the result of test 1. If you still have concern, write email to our course coordinator, Professor Mark Willoughby, or visit his office hours. Okay? Yeah. You're welcome. Yes.
I still confused of this equation why we should ask divide by 2.
Because we assume when this order is coming, the previous order sold out. There is assumption. Assume, if you go to next slide, assume when a new order is coming in, the old order sold out. I know that one is difficult to understand. Yeah. We tend to just X, not X over 2. Yeah, assume somewhere. Yeah, assume each shipment arrives just as the previous has been sold. So, and also look at this, we take the average, so that's why X over 2. This is X over 2 here.
How big a feather affects the S?